Okay, so now we're going to be investigating the idea of chemical reactions or chemical transformations. And to that end, we're going to start with the idea of how to balance chemical transformations. So how to understand from an atomic perspective how many atoms there are in the reactants and how many of them are produced in the products. Okay, so let's start with the idea of what is a chemical reaction. So a chemical reaction is actually nothing more than a way to take symbols, such as seen right here, and to translate it into words. So instead of saying NaSCl2G goes to NaClS, we would say solid sodium is going to react with chlorine gas to produce solid sodium chloride. And so in that previous example, the chemical equation is effectively the written representation of a chemical reaction. So that is our shorthand nomenclature to allow us to be able to understand what is going on. So it's the sentence. It's the sentence that describes our reactions, the chemical transformations. It just uses formulas as a shorthand to ultimately describe that. And so we might say something like, iron, Fe solid, undergoes a reaction with oxygen gas, O2G, to produce rust, Fe2O3 solid. The important thing about this whole process is not necessarily that we can describe the rusting here in words, but that we actually understand that there are some rules that must be obeyed. And the most important when it comes to chemical transformations is that matter in the universe is pretty set. So atoms, you can't create or destroy atoms in chemical transformations. They must be balanced. So that is to say that if you produce a molecule of Fe2O3 in your products, then you must actually have started with at least two Fe's, 2 irons, and 3 oxygens. You must balance before and after the fact from your reactions to your products. So one other thing before we begin doing some examples together, and that is there are these little additional kind of symbols that occur after our atoms or molecules. And this is, of course, a way to help us describe what's going on in the reaction, and it's a state of matter. So we're talking about liquids, we're talking about solids, we're talking about gases, and an AQ example, it would be an aqueous, and that's a dissolved salt. So in this case, this would be dissolved salt in water. Okay, so let's do an example of a chemical reaction. And so this is maybe something that you might get to do this evening if you're cooking on a gas-fueled stove, and you'll see these flames occur. And so what is the chemical transformation that we're doing here? So when we refer to gas, we're typically talking about natural gas, and natural gas is methane, that's CH4. And when we're burning something, we're talking about a combustion reaction. And that's typically a hydrocarbon source in the presence of oxygen, O2, and that is going to be producing two common products, in this case CO2 and water molecules. And so you can see here methane gas is going to react with oxygen gas to produce CO2 gas, carbon dioxide gas, and water gas molecules. And so when we're thinking about balancing these chemical reactions to make sure that they are true statements, we need to make sure that we have an equal number of atoms on both sides. And so if we start here and we look, we say, okay, well, we have 1 carbon on this side of the equation, and we have 1 in the product, so that's great. If we look here, we have 4 hydrogen atoms, and it looks over here that we only have 2 hydrogen atoms, and so we can't destroy 2 of the hydrogen atoms, so we know that this is at least right off the bat unbalanced. Similarly, if we look over here, we see that we only have 2 oxygen atoms on the left-hand side in the starting material, and magically we have 3 oxygen atoms appear in the products, which also is impossible. We can't actually create a new oxygen atom in this reaction. So what do we do? Well, the way you balance chemical transformations is you actually add more molecules to either side until everything is balanced. And so a true chemical transformation would be, in fact, to make sure that everything is balanced here, would be 1 molecule of CH4 can react with 2 molecules of oxygen to produce 1 molecule of CO2 and 2 water molecules. So this is actually balanced. And we denote the fact that we have 2 of the water molecules by this number in front, and 2 oxygen atoms by this number in front as well. And you can see here that now we have 1 carbon, so that's balanced. We have 4 hydrogens, and we have 2 times 2 is 4 hydrogens, excellent. We have 4 oxygen atoms, we can count them up, 1, 2, 3, 4. And then similarly, we're going to have 2 plus 2 here, that's 4 oxygen atoms. So everything is balanced, and so this is a true chemical transformation. So let's do another example. This is the thermite reaction. This is a very energetic reaction. It produces a lot of heat and energy and flames. And this is iron oxide. It's going to react with aluminum, and it's going to produce iron, and it's going to ultimately transfer the oxygen over to the aluminum to form aluminum oxide. And so we might look at this and ask, is this balanced? And we can kind of take this one by one. So right off the bat, so we have Fe2, so we have 2 iron atoms here, and it looks like right off the bat we don't. We only have 1 iron there, so that's no good. We have 3 oxygens and 3 oxygens, so that looks great. We have 1 aluminum and 2 aluminum, so we seem to have some problems here, but the question might be, could we add coefficients to balance this so that we actually can definitely do all the necessary changes to kind of swap around the atoms that we need? And the answer is yes. So let's think about this. So if we have 2 irons on this side, we need to put a 2 here to say we're going to produce 2 iron atoms. And if we have 2 aluminums in the product, that means we need to start with 2 aluminum solid atoms to begin with. And there we go. Here's a cleaned up version of this transformation, and you can see that we have this iron oxide, this nice pigment molecule. The solid iron oxide, or rust, is going to react with 2 equivalents, or 2 aluminum atoms, to produce 2 iron atoms and aluminum oxide, which is this kind of white powder.